Alrighty, we are live. We're back once again for another installment of the IBM Insight Chat video show. I'm your host, Ryan Boyles. I work on the IBM Global Conference and Events team. I'm a digital strategist and I'm responsible for our earned media programs. Today, we're going to talk about a very hot topic, especially for this conference. And I've got one of the most, I think, opinionated persons, and probably one of the foremost authorities on data scientists and what they care about in IBM. It's IBM's Big Data evangelist, James Kobielus.
Hey,
welcome to the show.
Thank you, Ryan, very much. It makes it sound like I have major attitude problems there. So
No.
I'll try to be agreeable. I'm very opinionated. I love that.
Well, you know what? Every time we've worked together a few times. I really appreciate that about you, because I think that's what's needed, especially in an industry like this that's full of jargon and buzzwords, and there's new technology and old technology kind of intersecting to make interesting things work. So this is the way this will go. I have sort of 4 big picture questions that we're going to talk about today, and we're going to get James to weigh in on these and really tell us, what's important in the areas of data science, what's important in with projects like Spark, which we've seen a lot of news about recently from IBM, related to that project, related to Hadoop and other platforms. We're going to talk a bit about IoT, Internet of Things, which is a hot topic, of course, but we're going to look at it from a different angle and talk about how it works with big data or how it doesn't. And we're also going to touch on a bit about a topic I really like, which is stream analytics and how it relates and works together with cognitive computing. So without further ado, I wanted to sort of jump into the first question. We're going to talk first about the industry's educational needs and talk about skill sets. So James, what do you think data scientists need to be effective? What skill sets should they really be looking at in what we are calling today's insight economy?
Yeah, that's a great question. First of all, let's talk about the role of data scientists in this new world that we inhabit, this new economy, the insight economy. The insights are derived from data and from statistical models, many more and more of them, I should say, that we're driving those insights into all of our business operations and into the way we deal with customers. And so fundamentally, when businesses consider how to staff for the insight economy, one of the core roles is that of a data scientist. Now, it's a fairly new term for an established set of roles that are really closely aligned with app development, application development in the world of big data analytics. A lot of it comes down to building the statistical and analytical models, predictive models, data mining, machine learning, was called deep learning or convolutional neural networks and the like. So that's the intellectual property, all of those models and algorithms that drive so much value in all aspects of our lives, in both internal operations and external engagement. The data scientist, as I began to sketch out the existing job categories that sort of encompasses, statistical, predictive, natural language processing, and the like. When you look at that broad category of roles, the data scientist is a number of things, or they draw on a number of skill sets. As I indicated, it's big data analytics, it's statistical analysis, it's it's predictive modeling, it's machine learning. And there's various and sundry different ways of doing all those things. Machine learning, for example, has supervised learning and unsupervised learning and reinforcement learning and so forth. And clearly, people go to college and get PhDs to master all of these areas. But you don't necessarily have to have an advanced degree to be an effective data scientist in the business world. What you do need is to be a smart person who is very comfortable and adept in doing statistical analysis. They're not, math doesn't make them faint, but it's applied math. It's
Right.
applied math that essentially involves not only doing the statistical analyses with the right kinds of tools, but being adept at visual exploration of deep data sets, of big data sets, in order to find patterns and correlations, anomalies, outliers, trends, and so forth that might be in the data but can't be easily seen by we mortal humans without statistical analysis power tools. Such as we, of course, and many provide in our SPSS portfolio in the context of our algorithmic libraries that we embed and incorporate into our big data offerings at IBM and so forth. So basically, data scientists need statistical analysis. They need the ability to do programming. They need to be able to program in languages like R that are very important, that are critically important for this new insight economy. They need to have domain knowledge increasingly. It's not just that they're a quant or a geek on math, but they need to be able to understand areas of business, like marketing, like customer relationship management, finance, HR, supply chain management, and so forth, because much of the work they do is very applied in each of these areas, and so their skills are not just to be the math geek on the analytics team, but also to know a fair amount about that area, so they can then do deep exploration based on their own understanding of how customers behave or how customers think, for example, in a sentiment analysis application that you might drive into marketing and all that. So the data scientist, to be effective, needs all of those skills: statistical, they need domain knowledge of a business area, they need programming skills, like I said, need visual exploration skills. They also need the ability to net it out in plain English terms for the vast majority of the stakeholders, people like you and me, and the CEO and others, who want to know, okay, how does all this data, how do all these statistical models translate into what's going on in our business and what we should do? So they need to be able to build the data scientist to be adept at building a data-driven narrative of cause and effect as elucidated by their models. So, on some level, they need to be an all-encompassing business professional who can really make the case for whatever their statistical models call out, and make it in a compelling way. So those are, essentially, when you look at the notion of a data scientist, to be effective in this insight economy, they need that full range of skills.
Well, it sounds like it's a very tall order. I mean, obviously we've read a lot about how this is sort of, like you said, it's a emerging space. It's an emerging role, and it's one that seems to be, it will be in high demand, right? There will be, I've even seen news reports that say that there's sort of going to be a shortage of maybe of these types of roles, and you can see why. There's such a sort of a breadth and a depth to this that is necessary. So when you look at, for example, the article that we're going to share in the show notes around this subject, it talks about there are programs where you can look at how you can get training and education around becoming a full stack developer. There are programs for that with companies like Galvanize out on the West Coast, but
who by the way are an IBM partner who we engaged with at the Spark Signature Moment last month. I want to point that out. Galvanize.
Yeah,
go ahead.
No, that's great. A shout out to Galvanize, and we have a good interview video from theCUBE with Mike Tamir at Spark Summit as well. Yes. in this blog post. So I guess it is something to watch closely, and the background math, the coding skills, the T-shaped skills, the communication skills, it requires someone with I think a lot of ambition, a lot of drive, a lot of curiosity, I think.
Yes.
So let's switch gears, and we're going to talk a bit about Spark itself. I think that you know a little bit about this based on the signature moment that we've had through IBM. But what can you tell us? I guess what I want to focus on with this question is how important is open source to big data technologies? You know, you can talk about Spark here, you can talk about Hadoop, you can talk about R, but really talk about these open source technologies and their real importance to not only the data science, you know, professional day to day in their job, but really talk about unlocking business value with open source technology.
Right, right. Open source technologies such as Spark and Hadoop and R, and there's various NoSQL databases, and you know, there's the open source world is vast and diverse. They're critically important in the insight economy because the insights that you're delivering from statistical analysis and big data and so forth are unlocked in the data based on, among other things, very important, communities of data scientists and business analysts and others working together to find these patterns and correlations and trends, and to assemble the data sets and to do the data preparation. And so this involves collaboration, which involves sharing, and which involves reuse of existing data and models and expertise and algorithms and so forth. Openness. Sharing rides on openness, open platforms, open data, open knowledge and skills. So open source technologies are critically important in this fundamental equation to maximize the distillation of insights from the data that exists both in your organization and in the larger world. There's about 10 zillion open source data sets that one might tap into in any given data science initiative. So looked at, you know, in this context, then the most critical open source and most fundamental open source technologies in this insight economy are Hadoop, first and foremost, a mature technology now as the heart and soul of many companies, big data strategies and implementations. And clearly we, IBM, we provide Hadoop offerings and software in the cloud and so forth, and we're one of many solution providers in this area. You know, it's an Apache project, just like Spark is. Spark actually is a component of the overall Hadoop distribution. People don't realize that. The current version is Spark 1.4. It's included in the core Apache Hadoop distribution. But Spark in many ways is the nucleus of a completely new market and a completely new community. It's more than just a nucleus. It's a substantial community in its own right that has essentially evolved Hadoop to address new challenges in the insight economy that are related to streaming analytics, related to in-memory, distributed in-memory and distributed computation in memory at a much higher speed than traditional Hadoop. And I hesitate to use the word traditional in a market like Hadoop that's so young, but traditional Hadoop is geared more towards batch data, whereas Spark is more towards real time. But they work together, they're complementary. So Spark is very, very important. It is a substantial community in its own right. It's a substantial emerging market that clearly IBM, we see strong potential for Spark to become fundamental, as fundamental before long to most enterprises' big data initiatives, as Hadoop already is, and that's why we've placed our bets, as it were, in this new market. And there's all those announcements we announced in the month of June. You know, our viewers can look them up. So Spark is critically important, but R is just as important, or even perhaps more important than Hadoop and Spark, for the simple reason R is the core language for data scientists to do their work in. It's an open source language. It's been around for about 10 or more years now. I've lost track, but it's a mature language that is used everywhere. And so to unlock insights in this economy, data scientists rely on R, and R is our models, our code is written everywhere, and it executes in many disparate big data platforms, be they open source like Hadoop and Spark, or be they, as it were, proprietary or closed source. R is the lingua franca for the core work that data scientists do in this new economy, and it's completely open. So Spark, Hadoop, and R are the core, quote unquote, stack for productivity in this new economy.
That is, I love hearing folks talk about R. I've been to here in Raleigh, at least, big data meetups. There's lots of companies here, not only IBM but Red Hat and other folks that are working in this space. So there's definitely a lot of buzz around that, and a lot of interesting industry applications. So in order to talk about that, I think we ought to touch on this article about Chaotic Moon, which is it talks about how Watson infers traits about an audience in real time.
Yes.
And I think it's using sort of some of the stream analytics stuff, which I think it's really powerful. So what can you tell us about sort of real-time immersion in these audience analytics and sort of the tailored messaging that you can accomplish with this, and response metrics that are really key to engagement, I think, right?
Yeah, well, in the real-time, in the insight economy, real-time analytics on mobile data, on social data, on geospatial data, on sentiment data, and so forth are critically important, because it all comes down to, much of it comes down to trying to understand what your customer is doing, thinking, and feeling, or how they might behave or respond or feel under various future scenarios that you can do predictive modeling on, to get inside really how to make customers happy, how to satisfy them, how to placate or remedy when they are not happy, how to determine in real time whether your campaign, for your marketing campaign or product launch or show, maybe you're a TV programmer streaming, maybe you're Netflix, maybe you're trialing a new series online, you want to know right away whether in fact your customers, or your target market, I should say, target audience, are responding the way that you expected, positively, negatively, maybe at a microscopic way. You want to know whether the last 15 seconds, was interesting enough to them, based on what? Based on what they're tweeting, based conceivably on other behavioral data that you might be gathering in line to, let's say, a mobile session or whatnot. So it's all about streaming analytics. It has to be low latency, continuous, real time. You got to be able to analyze it in real time, possibly many different streams in parallel from a vast audience. The audience might be millions of people, it might be thousands of people, whatnot. But you want to know, you want a quick roll up that's continuously updated about what the target audience is, how they're reacting, as a way of then tuning your strategy either in real time to change, maybe how you present the programming or the information or the navigation model in line to, say, your mobile app on a dynamic basis, or maybe to use that streaming data and analytics as fodder, as it were, for planning future or prioritizing future offerings or programming to suit or to interest this particular target market. So that's not just in media and entertainment where this comes in, but we see real-time audience analytics used everywhere in the business world, in every market, to gauge on an ongoing basis how the audience is reacting to whatever you're putting out there. We, IBM, used that last month on June 15th when we made these announcements all around Spark. Among other things for IBM, I managed the technical marketing beat of the Big Data Analytics Hub. So we were looking throughout the day, on that day, at our chief handle, on our chief hashtags and so forth, to get a sense for who's responding, who's saying what about what we're announcing and so forth. It was eye-opening. And so we're not atypical as a company doing marketing in this new online world. We want to know in real time. We may or may not use that intelligence in real time to plot a response, but it's better to know right away rather than at a week or a day or a week or a month later.
Well, and this also allows for, we've talked about how this also can allow you to build some predictive capabilities in. But one thing I wanted to really touch on with this use case in the article was, they, like you said, using the technology at the signature moment launch. They likewise used some of the Watson technology
Yes.
as part of the launch of the Watson, office location. And two real key things jump out at me. One, they were able to use the new Watson Developer Cloud on Bluemix, and Bluemix is IBM's platform as a service offering, of course. But this goes back to our original question of tools that are key for data scientists. So they were able to not only use the Watson Developer Cloud, but use features in Watson like personality insights to really tap into linguistic analytics and use things like messaging resonance to
emotional resonance.
To figure out what is happening with their Chef Watson demo that they were putting on display for all the guests at the new office at Astor Place in New York. So
what's fascinating about that is that Chef Watson incorporates machine learning, which of course is developed by data scientists at its very heart, but also audience analytics and emotional resonance. Everything that Chaotic Moon does is also using machine learning in that case to get inside people's heads, as it were, or their hearts. How are they reacting? How are they responding to whatever it is they're seeing or experiencing? What we're talking about with Watson here, these and Chaotic Moon and all these capabilities are fundamental to the new work of marketing everywhere. It's like some people may be creeped out by the fact that that big businesses can intuit or infer with a high degree of accuracy how a demographic or individuals are feeling or responding. That's just sort of part of the way it works now in the social world, is where you are choosing as an individual to share out this information in the simple act of using a mobile app or being on a social network, but you're getting value in response. Because what's happening then is that, say, whatever the experience that you're having in this environment like Chef Watson, it might be tailored to your specific needs in line in a predictive way, better than human beings on location, let's say at these various sites, could do themselves. So actually big data helps to deliver better value, to more targeted value, more personalized value in lots of these kinds of scenarios, based on the power of statistical. Well, fundamentally, it's all about statistical models that are derived from data that you are choosing to share.
Yeah, it's fascinating to me to see this stuff in action, and really I'm excited to see when we host hackathons like the one in the story, or at our conferences like Insight in October. It's really interesting to me to see people sort of, a light bulb comes on when you think about these capabilities being at your fingertips in this environment like Bluemix, and to see kind of some of the new challenges that can be tackled here. It's not just gee whiz stuff either. I mean, there's some big challenges that I think can be addressed with this technology.
Well, one last thing I want to point out, not the last thing, but I just thought about a connection here. I read an article in the Wall Street Journal today. There was a headline. It's like, is your Wall Street analyst a robot? That was the headline. Is your Wall Street analyst a robot?
Right.
In fact, to an increasing degree, he or she is. And that's not something to worry about. In fact, that's a good thing. A few years ago in a blog, I put out the concept of your next best expert. Who is the next best expert in any problem domain or situation you may be confronting, such as how to invest your funds, like your retirement funds. And so humans have insight and judgment and intelligence that no robot, no algorithm can match. We all know that. But robots, aka big data analytics and decision automation and process automation capabilities powered by machine learning, have insights in their own right that no individual human can expect to derive, so let's say in real time, from petabytes of data. So when you think about Chef Watson, I'm going to key on the concept of Chef Watson, which of course is driven by algorithms and data, and, in real time. There are human chefs who can physically taste what they're concocting and then decide whether there's too much salt or not enough or whatever, or sugar or whatever it might be. Yeah. And then there's robotic capabilities like Chef Watson that can do some cool things like real-world experiments in terms of identifying the likely recipes that may appeal to particular consumers under particular scenarios with particular ingredients that no human chef can see all, unless they're a genius, can intuit the full range of potential combinations of ingredients and ways to prepare them. And a robot can help to size up and rank the relevance or the appropriateness of different options in a way that a human may not be able to, and to sift through them and identify which are more likely to appeal to a human. The human experts, aka real-world chefs, can then sort through that list further and determine, okay, some of these are not feasible, some of these are not, we've tried them, they're not good or whatever. And they the human chef might know probably does know their customers better than Chef Watson on a personal level. It's a personal relationship with your cook. So what I'm getting at is that your analyst is a human and a robot, and the human and the robot play together. Human chefs can use and do use Chef Watson to accelerate their productivity. And fundamentally, it's all about making customers happy, satisfying them.
Well, and it's also about preferences and learning those behaviors, learning those preferences. And I'm excited to see an application, for example, with the use of taking Chef Watson a bit further even, and saying, okay, if you are gluten intolerant or dairy intolerant, how do you incorporate that sort of the healthcare angle into your diet? I think the possibilities are endless there, because it's not only the real world application of fixing your meal, but it's bringing in those aspects of your lifestyle or your health into the equation.
Right.
So I think this is a perfect segue to go into our last story for today's chat, and to really talk about sort of the intertwining interdependencies between, as you've said, humankind and technology. The lines between the physical and the digital world, we talk about them being blurred all the time. And I think that's the perfect setup to talk about this big picture question, which I know you love, which is, how does big data and the Internet of Things work together, do not work together yet? Where are we right now? Where are we headed with these technologies sort of being complementary or working together in concert?
Yeah, Internet of Things, and really use the term sensor internet, sensor and SENSOR, internet, as being pretty much a synonym for it. The Internet of Things is already here, and in a big way. It's been around for a long time. In the industrial world, it was called things like machine to machine, M2M. In the world at large, including especially in the consumer space, it's embedded essentially into, as a capability, into your smartphones, into your, healthcare monitoring devices, into things like connected cars and so forth. So we're seeing things like healthcare or fitness bands like Fitbit and so forth, and wearables in general, wearable devices, Apple Watches and the like. These are all, as it were, endpoints on the Internet of Things, and they're becoming a standard part of our wardrobes, a standard part of just how we live.
Yeah, I'll show you right now. I've got mine on. So in the consumer world, they're a reality and they're becoming ubiquitous. I mean, you look at the success already of the Apple Watch.
And I don't have one yet. I don't need a physical watch of any sort, but I'm probably atypical.
Mm-hmm.
If you, in smart homes and so forth, smart appliances, these are all the Internet of Things. In a big data context, the Internet of Things, these endpoints, the things, are becoming in the aggregate the largest source of data for big data in the cloud, and essentially the largest consumers of that data are the analytics derived from that data, because the analytics themselves, machine learning models that can sift through petabytes and exabytes of this data and find patterns. The data will live in the cloud, and the analytics will live in the cloud. The horsepower to process all of this in real time, it's streaming data, will live in the cloud. But the analytics will then drive, there's often called next best actions across the Internet of Things, like connected cars are a perfect example. As they come more completely into the mainstream and become dominant, it's geospatial coordinates. It's the coordinates from your location system embedded in that car, which is, that's the Internet of Things right there. It's all of the readings from your engine. It's all of these, the readings of the environment, the roads, the weather, and everything. It's all of the readings from inside the passenger compartment on your entertainment and your comfort level and so forth. All of these are increasingly feeding into cloud-based applications that can then send control signals down. If it's a self-driving car, there aren't that many yet. They're still experimental, but they're clearly coming along. The self-driving car will take real-time, up to the split-second guidance from the cloud that supplements its own ability to steer that vehicle and avoid crashing it in a way that the vehicle in isolation won't be able to do, won't have the intelligence to do, for example, rerouting of a car based on system-wide or region-wide traffic data, for example, or incidents that might be happening somewhere 5 miles away. What I'm getting is that these kinds of real-time next best actions, like turn here so you can avoid a traffic tie-up 2 miles down the road, these will be the unseen but fundamental implementations of the Internet of Things in the insight economy. These are robotic instructions being sent down to robotic endpoints, like your smart car, that will serve our needs based on all these environmental variables, but also based on your intentions and plans and so forth. Because the self-driving cars, for example, to use that example, continue with that example, they're not going to tell you where to go generally. Rather, they're going to take instructions from you about where to go. Either it's your regular routine, your regular commute downtown, whatever, or the instruction might be simply, you're gonna speak it as you get into the car, like, take me to the coffee shop 2 miles away and park in my usual space if it's available, that kind of thing. So fundamentally, when you're looking at scenarios like that, it's the big data is, like, as it were, the secret sauce in the cloud, but it's these machine learning models in the cloud that are leveraging that big data to drive control signals down to the endpoints, like connected cars, but also smartphones, like you carry around. Smartphones are the most ubiquitous endpoint on the Internet of Things. And giving guidance to human beings, decision support, about what to do and where to go, what to buy, and so forth. This capability, this set of capabilities is so fundamentally embedded in the world global experience of being a human in the 21st century. We after a while we'll just tune it out. We'll just take it for
I would
granted.
say, would you say that we've already started to tune it out? I mean, in a way, I think, like you said, with the mobile phone, the ubiquity of the smartphone now, it seems like we're already, I think already everyone is already a part of this, the cloud and the Internet of Things, and they're contributing to the quote unquote big data sets. So they're already connected whether they know it or not, and they're contributing more and more each day. So I think it's something that, you're right. You don't have to even be conscious of it to get the benefit of the end result.
Oh, and yeah, that's true. And then one last point I'm going to make. The shape of big data, I'm going to use the term shape in a very broad sense, is changing and it is being, the changing shape or the changing architecture of big data needs to change and will change as driven by the Internet of Things, because the Internet of Things is very much all about the network edge. Everything is geared towards serving the edge of the network. That's the things themselves. They're the sensors, but they're also the actuators. In other words, they're what's actually taking action increasingly, or driving actions, like in a self-driving car. So fundamentally, what's happening then is that more and more data is being persisted at the endpoints or close to the endpoints to drive real-time actions. And more of the analytics will live and execute close to or at the endpoints. We'll see more machine learning models and deep learning models and all that embedded over time going forward in your smartphones, in your connected cars, in your whatever, so they can operate autonomously, or they can operate in connected mode with each other locally or globally with broad, say, fleets of cars or buses or whatever it might be, or airplanes and whatnot. So what that means is that big data then is becoming decentralized out to the endpoints. It's going to live entirely in memory from end to end. When I'm saying entirely in memory, ultimately, for the next 10 to 20 years, we're going to have a world where we have ubiquitous, all in memory, statistical learning and machine learning and so forth, operating worldwide in these petabyte and exabyte and beyond clouds. So the Internet of Things will live entirely in that distributed environment. Big data won't be, we'll still have data centers, but mostly we'll have data decenters, decentralization in a fairly radical way. I've heard predictions about the data center is going to go away in its current form. I believe that. Really? As more of the data lives closer to the endpoints, and I'm not just talking about in the consumer economy, I'm talking about in the business world too, as Internet of Things endpoints are essentially embedded in the very fabric of business, in facilities and all equipment and all devices that are used everywhere. The more of the data, the vast majority of the data won't live in a server farm.
Well, that gives me.
It'll be managed in the context. There will be server farm, but it'll be federation and decentralization and virtualization and all that stuff will become fundamental to the fabric of big data. But that's we're talking about a long-term, like, well, 5 to 10 to 20 year process.
It's very, very interesting. It gives me a lot to chew on, actually, and I think you've got my gears turning now. I'm not sure if there's smoke coming out of my ears, but I think this is a perfect setup. I mean, we could talk about this. We could go on and on, you and me, but I think what we ought to do now is sort of take a deep breath and really, I guess, invite everyone to come and join you and I in Las Vegas in October. Yeah. We're going to be talking about all of these subjects and more with our peers in IBM, with lots of great speakers that are clients of IBM, that are business partners, like we mentioned today, that are going to be talking, presenting, doing labs. We're going to have, specifically at Insight this year, as we started last year, we're going to have a specific developer-centric program called Dev at Insight, which is, a cool way for folks to get their hands on this technology and to talk to folks that are have their hands in code. I know you gave a lightning talk and Ignite talk there last year. So we're going to continue to do some of those neat things. But I wanted to just also give the opportunity for everyone to connect with you, Jim, and I via the internet. So I wanted to give a shout out to your Twitter handle and mine. So at James Kobielus on Twitter, or at the Rab is where you can find both of us. And I wanted to also encourage everyone to follow along with some of these conversations, ask questions via Twitter, and use the IBM Insight hashtag to do so.
Oh, and one last thing, let me plug, of course, IBM Big Data and Analytics Hub. And the URL for that is IBMBigDataHub.com, where I am not only we call it the beat lead for all technical marketing content. I'm one of the star bloggers, as it were, and we intend to publish a steady stream, not streaming analytics, but a steady stream of blogs and other content assets related to Insight 2015 in the roll-up to the show. And we're going to be having guest blogs by any number of the committed speakers who are such as especially business partners who'll be at Insight 2015. So stay tuned to the Big Data Hub as well. And really, we'd love to have you. All of our readers, we always love your feedback, and if some of our readers would like to author blogs and so forth, I'm more than happy to entertain any proposals. We have a lot of smart people out in our customer community, our partner community. We invite you all to join us on the hub.
That's perfect. And you know what? You're also reminding me that another reason to pay attention to the IBM Insight hashtag, as well as your Twitter handle, the IBM Analytics Twitter handle, the IBM Big Data, is we're also going to host a series. Not only are we doing these video chats with our team and your team and lots of folks that are also part of the influencer program that are voices in this space, but we're also going to be hosting a series of Twitter chats on the crowd chat platform, and we're going to host, I believe, the first crowd chat for us, Jim, is going to be on the industrial Internet of Things, and it's going to be held on July 23rd. And I know we're going to have a whole series of these, but you'll be able to find out a lot more information about this on the Big Data Hub on the events page. We're going to have that information for you next week. And with that, I think we're going to end this week's chat and encourage everyone to join in the program, share the replay with your colleagues and your network, and join us for the next show in 2 weeks. So thank you, Jim.
Thank you, Ryan. Have a good day, everybody.
Goodbye.